Welcome to another session of Ebenezer GATE coaching classes. This is a problem that appeared in GATE 2015 for 1 mark. It's a numerical aptitude type problem. In the circuit shown, assume that diodes D1 and D2 are ideal. In the steady state condition, the average voltage VAB in volts across the 0.5 microfarad capacitor is dash. Here we have two diodes, D1 and D2. The input is a sinusoidal waveform with a peak at 50 volt and the negative peak at minus 50. So D1, diode D1 conducts when the input is negative. So when the input is negative, the N junction of diode will be negative and hence D1 will be forward biased. So when the input reaches the negative peak of minus 50 volt, the capacitor will be charged to minus 50 volt. So the voltage at this point will be 50 plus 50 sin omega t. 50 plus 50 sin omega t. So that is, if you draw this actually, instead of starting at 0, the sine wave will now start at 50 sine wave will start at 50, go to 100 and come down to 0. So the peak will be 100 volt and the minimum will be 0. So now, since it is always positive, D2 is going to conduct and charge this capacitor of 0.5 microfarad and it will get charged to the maximum value. So the maximum value here is 100 volt. So this will be the charge across this capacitor. Now once this capacitor is 100 volt, the voltage here is 100. The voltage here is 50 plus 50 sin omega t. And we know that 50 plus 50 sin omega t is always less than or equal to 100. So this D2 is going to be, is not going to be in forward bias state because it's always going to be less than 0. And D1 also is going to be reverse, going to be in the off state. So then the capacitor voltage will remain at 100 volt, which was initially charged to 100. So in the steady state condition, the average voltage VAB across the 0.5 microfarad capacitor is going to be 100 volts. Thank you. God bless you.